o'clock.
Oh, no, that is how it's that was
I'm not sorry. It is not an option. I found that. I'm looking at that one. I'm not doing it. I'll just do it. It feels good. You're like, oh, it's good weather. It's gonna rain.
Good morning, guys. Thanks. We're going to go ahead and do section 4-7 today. It is a pretty quick lesson. Usually this stuff is pretty easy. And then once you guys finish the homework, we've got a quiz scheduled for Monday. So I'll try to put together a quick quiz outline for you. That way you'll know what to expect on Monday. It's from 4-5 to 4-7. And I think 4-5 we did a little bit before spring break. So I've got some worksheets to pass back to you for that stuff. And I'll try to just kind of review some of that stuff with you. But in this section, we are integrating inverse trig functions. Now, there are 6 of them: inverse sine, inverse cosine, inverse tangent, inverse cosecant, secant, and cotangent. But we are only going to work on 2 of them here in Calc 1. So I labeled this more integrals, because this is just going to be a couple more that you need to add to your list. We've got our natural log integrals. Now we've got these. We have regular trig integrals. So the list keeps growing. But the first one that I have up here is for inverse sine. Remember, inverse sine and arc sine are the same thing. It's just 2 different ways to write it. So if you have, and I'm going to put these down on the side so we can look at them again later. If you're integrating du over the square root of a squared minus u squared, it works out to be the arc sine of u over a plus c. Now, I do want to point out that there's another way this integral could be given to you. As it is right here, the du is on top of the fraction. It may not always look like that. You could also see that with just like a 1 on top over the square root of a squared minus u squared. And then the du might just kind of be out to the side. So just pointing out those 2 integrals are really the same. Now, the only other inverse trig function we're going to work with today is arctan, or inverse tan. So if you are integrating du over a squared plus u squared. We'll talk about a and u a little bit more here in a minute. But that works out to be 1 over a arctan of u over a plus c. And again, that integral could be written a little bit differently. It could have the 1 on top like that, and then the du could also just kind of be out to the side. Now notice both of these are dealing with u and a, but for the most part I'm worried about u. Whatever u is, you're going to need to, I'm going to write this down here, make sure du is in the integral. It's just like, or maybe I should say in the integrand. Make sure du is in the integrand. It's like the typical u substitution stuff. If u is 2x, du is 2, and if you don't have a 2, you need to put a 2 over here, pull a 1/2 out front. We are still going to see some of that stuff today. So something else to point out here, I mean, the first thing I'm going to do is I'm going to try to pick out, is it going to be arcsine or arctan? Now, couple things to look for. If there's a square root on bottom with a minus, that's the giveaway that it's going to be arcsine. If there's no square root on bottom with a plus, that tells you it's going to work out to be arctan. Then you can kind of worry about all the other details. Okay, so the directions still say to find the indefinite integral. And remember for the quiz on Monday, and really this is how the test will be too, it's not going to say in the directions to use an inverse trig function. It's going to be another one of those things where if you try something else and it doesn't work, think about your other options. So this is just a couple more options that we have to integrate. Now, since we're just learning it for the first time, it's pretty much all that we're going to be using in our lesson today. All right, so number one, we are integrating dx over the square root of 16 minus x squared. Now, like I mentioned earlier, the first thing I want to do is figure out, is it going to be arcsine or arctan? This has a square root on bottom with a minus, so it's matching up to arcsine. We need to figure out what A is and what, I almost said B, but what U is. A and U. We need to know what those two variables are. So I'm just going to write this out to the side here. It looks like arcsine. I know it's going to turn into arcsine. So let's go ahead and talk about A and U. I'm going to have to use both of those in my answer. So I want to figure out what those are. Now, matching that up to this, the first part under your square root is A squared. So if A squared is 16, what is A? 4. It's what you squared to get that 16. A squared was 16, so A has to be 4. The second part is the U squared. So if U squared is x squared, what is U? X. Yeah, what you squared to get x squared. Now, keep in mind, you got to make sure du is in the integrand, but we kind of lucked out here. Du is just 1 dx. You don't have to adjust by a 1. You could put a 1 up there anytime. So I don't have to put anything here or there. I'm going to leave it the way it is. Now, let me follow this formula. I'm going to call it a formula. I need to go with arcsine of U over A. So again, U for us was X. A for us was 4. Don't forget the plus C, bless you. And that would be it. As long as you can find which one it is, and then what A is, what U is, usually it works out pretty nicely. Okay, now let's try some more. That might require a little bit more work. Example 2, we're integrating 4 over 9 plus x squared dx. This time the dx is out to the side. So, looks like I've got no square root on bottom and a plus sign. So it's looking like arctan. I know I'm going to integrate it using arctan. So going with A and U, you don't have to lay them out like I am every time if you don't want. But this first part, according to that, it's supposed to be A squared. So if A squared is 9, then A must be 3. And we had this one last time. If U squared is X squared, then U is just X. Now, when you go to do du, it's a 1 again, but this problem is slightly different because you've got this extra 4 on top of your fraction. You can just think about pulling that 4 in front of your integral. I'll even rewrite that if you want to see it that way. Pull the 4 out front. You don't have to do the reciprocal or anything like that. We're just getting rid of it. So now du is what it's supposed to be. It's supposed to just be 1 dx. So when you write your answer, the 4 is going to be out front. It is going to get multiplied by the 1 over a that you're also supposed to have out front. That would be 1 over 3 in this problem. Then arc tan of u over a, so that is x over 3 plus c. Now I need to make that look better. 4 times 1/3, that would just be 4/3 arc tan of x over 3 plus c. Any questions so far? Say these aren't too bad. I'll keep on rolling here. Number 3, there it is. We are integrating 7 over 1 plus 4x squared dx. I already kind of know from the last problem that I'm probably not going to want the 7 on top. Sorry about you, 7. But I'm going to pull that out front, so then I won't have to worry about it when I go to do the du part. Now, whichever one you look at here, it does, again, resemble the arctan formula. So I'm going to be using this, but let's think about a and u. If a squared is 1, then a must also be 1. Now, if u squared is 4x squared, what would u be? 2x. Now that means du is 2 dx. This is the first time we've ever had to do something about the du. So to get the 2, I'll put it right there, but I have to pull a 1/2 out front. Now there's a lot going on out front, so let's kind of put it all back together. The 1/2 times 7 just makes 7 halves, so I can go ahead and put that down. Now integrating with arctan, you also need 1 over a out front. So this 7 halves is going to get multiplied by 1 over a. Now a is just 1, so 1 over 1 is not really going to do much for us. Arctan of u over a plus c. I need to make this look better. 7 halves times 1 is just 7 halves. And 2x divided by 1 is just 2x. You don't need to keep it over 1. Okie doke. No square root on bottom with a plus. It's going to turn into arctan. If there is a square root with a minus, pretty good idea, that'll be arc sine. Now there's 3 more, I believe, and I just want to show you some other stuff that could happen. Number 4, 1 divided by, it's the integral of 1 divided by the square root of 1 minus x plus 2 squared dx. Is it going to be arc sine or arc tan? arc sine. Now A and U. The first part is the A squared. So this is like last time. If A squared is 1, then A is 1. This part is U squared. If U squared is x plus 2 squared, what is U? X plus 2. It's almost like when you go to find A and U, you're taking the square root of both of those terms. That's kind of what you get. Now, du for this is just 1 dx, and that's exactly what I have. I don't have to move anything around. So, I mean, arc sine, you don't even have anything out front. This is just going to turn into arc sine of u over a plus c. Now that's a quantity, so I should probably put it in parentheses. And I really don't need the 1 on bottom. When you write your answer, though, when you get rid of that fraction, you would have to have parentheses around the x plus 2, because all of that is with the arc sine. Okie doke. Stop me if you have any questions. I'm going to keep on going here. Usually a pretty quick lesson. Number 5. This one's kind of different. 2x over x to the 4th plus 16 dx. That's what we are integrating. Okay, I don't see the square root and I see the plus, so I'm thinking arctan. Now, A, if you follow our formula for arctan, A is supposed to come from that first term. So if A squared is x to the 4th, what would A be? X squared. Again, it's kind of like taking the square root of those terms. Now, u squared is 16, so that means u would have to be 4. Now, this is kind of the weird part. When I go to check du, what's the derivative of 4? 0. Derivative of any constant is 0. And that's no good. Because, I mean, if this was 0 dx, then you would be integrating 0. You don't have 0 over here. So what I've got for du is not matching up to what I have over here. You can't just put a 0 here and then do the reciprocal, because the reciprocal would be 1 over 0, which is undefined. So any other ideas what I could do to this to get it to match up? Yeah, addition is commutative, so this really could be written as 16 plus x to the 4th dx. You would not be able to do this for arc sine because it has a minus. But for arctan, you definitely can do that if what you need for du is not matching up. So A is actually 4. And u is x squared, and that works out really nice because derivative of that would be 2x dx, and you've already got it. So following our formula for arctan, I'm not using that, I'm using that stuff. 1 over 4, that's the A, 1 over 4 arctan of u over a, so that is x squared over 4 plus c. You wouldn't really be able to simplify that any further. Alrighty, any questions on number 5? Now, last one here. This is number 6. And it's the integral of cosine of x divided by 6 plus sine squared of x dx. Now again, thinking about the quiz Monday, I'm not going to tell you when to use those. It's going to be something you kind of have to just think about. So, other options to integrate this would be pretty limited. If you pulled this quantity to the top, it would be to the negative first power. And if you tried just normal U substitution, it's not going to work out real well when you try to take the derivative of sine squared. It's not going to match up to what else you have in the integrand. Other options we had were natural log, but again, if this was U, to take the derivative of 6 plus, not U, x, 6 plus sine squared of x, derivative of 6 is nothing, but for this part, I kind of want to think of that as sine of x squared. I would have to use the chain rule, pull the 2 out front, make it to the 1 less power, go back and take the derivative of the part on the inside. That's not matching up to what I have either. I could get the 2, but I couldn't just throw in a sine of x to the integrand. So that would not work out either. If you've exhausted all other options, then you can start to think about these. Arc sine is a little bit easier to recognize because of the square root and the perfect squares. Arctan is not as easy to notice because it doesn't have a square root, but again, try other stuff first and just see what happens. So A should be, well, this is kind of weird. If A squared is 6, what would A equal? Yeah, it would equal the square root of 6. It's kind of like taking the square root of both of those terms. If you aren't sure that you did that right, take this number, square it, and see if you get back to that. You would. If you square a square root, they would cancel and you just get 6. Now, if U squared is sine squared, what would U equal? Just sine, yeah. And then what was the derivative of sine? Cosine, and I like the sound of that because I already have the cosine that I need. So you don't have to adjust by anything. It's just what you want. Now, we will have to work on our answer a little bit because of the square root, but let me just start to piece it all together. I need 1 over A, and I don't like that because I got a square root on bottom. I'll have to fix that here in a second. Arc tan of U over A. I don't like that either. I'll have to fix that here in a second. Plus C. Last year in trig, we rationalized denominators a lot. So if you forgot how to do that, whatever your square root is on bottom, multiply by that square root on top and bottom. So this really should be written as square root of 6 over 6. Square root of something times the square root of the same something is just the something. And even though this is kind of weird right here with the sign on top, you can still rationalize that. And I don't know, I would maybe just put the square root of 6 in front of the sine of x. You wouldn't really have to do it that way, but I'm afraid if I put it in the back, it'll look like it's with the sine of x. So it'll just kind of be separate there, and then there's the plus c. Okay, to get A and to get U, it's like taking the square root of both of those terms. Any questions on that? All right, so homework I don't think usually takes too much time here. This is C89. You turned in C88. So this is 89 from page 359. We've got 1 and 2, 4 through 7, and then 9 and 13. It's not 9 through 13 unless you feel crazy and you want to do that. It's just 9 and 13.